I am G. Kumar, working as a lecturer in Electrical and Electronics Engineering, Institute Government Polytechnic Yadarigutta. Today I am teaching the subject is nothing but the basic electrical engineering, that is the topic work, power and energy, subtopic prefix for SI units and work, power and energy. Again we see the work, power and energy. The work is said to be done in the case of electrical systems by passing the current through the conductor or the coil. By applying the voltage, some work can be done. Again we can say it is nothing but the electrical circuit which is having the two resistors are connected in the series. We are applying the voltage again here R1 and R2. Again R is equal to, we can say here R1 plus R2. So it is nothing but the electrical circuit or electrical system.
Six 110 6 110.
Again here is the resistance R is equal to R1 plus R2. So here we are applying the voltage, again the current can be flows through the circuit here. Here some work can be done by passing the current through the two resistance R1 and R2 here. Again we can say the power is nothing but the, again the total amount of the work done again is nothing but the power. Again is nothing but, again we can also define the power P, which is equal to V into I, that is nothing but the power can measure in watts. Again energy is nothing but the total amount of the work done in the case of electrical systems is nothing but the energy. So now we see the prefix for SI units are and work, power and energy. In the previous period we have discussed problem some series and parallel combination circuit. On completion of this period you would be able to know prefix of SI units, correct use of symbols for SI units, work as electrical quantity, work as thermal quantity, prefix symbol. To 10 to the power of 24 we can say is a iota, that is indicated by the Y. 10 to the power of 21, that is nothing but the zeta, that is indicated by Z. 10 to the power of 18, that is nothing but the hexa, indicated by E. 10 to the power of 15, that is nothing but a peta, indicated by P. 10 to the power of 12, that is nothing but a tera, indicated by T. 10 to the power of 9 we can say it is nothing but the giga, G, indicated by the G. 10 to the power of 6 is nothing but the mega, indicated by the M. 10 to the power of 3 is nothing but the kilo, it is indicated by K. 10 to the power of 2, that is nothing but the hectare, indicated by H. 10 to the power of 9 is nothing but deca, indicated by dA. 10 to the power of minus 1 decimal, that is indicated by D. 10 to the power of minus 2, that is a centimeter, indicated by C. 10 to the power of minus 3, that is we can say milli, indicated by M. 10 to the power of minus 6, that is nothing but the micro, again indicated by mu. 10 to the power of minus 9, that is nothing but the nano, again indicated by N. Then we can also say here 1 microfarads. You can say here 1 into 10 to the power of minus 6. So 1 micro is equal to 10 to the power of minus 6. 10 to the power of minus 10, that is nothing but the pico, indicated by P. 10 to the power of minus 15, that is nothing but the femto, indicated by F. 10 to the power of minus 18, that is nothing but the atto, indicated by A. 10 to the power of minus 21, that is nothing but the zipto, indicated by Z. 10 to the power of minus 24, that is nothing but the yocto, indicated by Z. So correct use of symbols for SI units, that is while writing an SI unit in full, do not start with capital letter, but if the unit is named after a person, the symbol of the unit must be a capital letter. So correct, incorrect, joule, incorrect is nothing but the, we have to does not write the caps J here. Newton and Newton, meter M meter, hertz hertz. Use number of no plurals for the SI units, correct, 10 newtons. incorrect. Newtons, 2 kilogram, correct. 2 kilograms, incorrect. 5 seconds, 5 second, correct. 5 seconds, incorrect. Use proper spacing between numerals and symbols or between two symbols. X, correct. That is nothing but the 15 Newton meter. 15 Newton meter, correct. 15, does not write the meter. Again, closer here. So don't use space between prefix and symbol of the unit. That is X, correct. Incorrect. 5 milliamps, correct. Milliamps. Kilowatt, kilowatts, kilowatt. In the product of the mass and acceleration, F is equal to m into a, measured in newtons. Again, if m is equal to 1 kg, 1 meter per second square, then F is equal to 1 newton. 1 newton is that force which can give an acceleration of 1 meter per square to the mass of 1 kg. Gravitational unit of the force is kg watts. That is the force with which a body is attracted towards the center of the earth is called the weight of the body. If m is the mass of the body in kg and g is the acceleration due to gravity, that is made in meter per square. Weight m is equal to m into g newtons. 1 kg weight means weight of the mass. That is the mass. 1 kg weight is equal to, we can define that is nothing but the weight of the mass, that is made in kg here. The weight of the body, 9.81 newtons. So 1 kg is equal to 9.81 newtons here. So the current may be defined as the rate at which the electrons flow or moving along the wire gives the current here. Again, we can say it is nothing but the wire which can be connected to the voltage. Again, we are applying the voltage. Again, here the current can be flows. Then we can define these are nothing but the electrons which has moves all along the length of the conductor. You can say these are nothing but the electrons, E. So again, it is represented by the letter I measured in amperes. The current can be indicated by the letter I and measured in the amperes here. Again, it is nothing but the, again here, current. Again, these principle can be indicated where the coil can be rotates. The two ends of the coils are connected to the two slip rings, and we can say these are nothing but the slip rings here. Rotating is nothing but the coil or a conductor or wire. Again, these are nothing but the electromagnets, EM. So again, this principle can be applicable in the case of generators. We can say this is nothing but the moving coil here, moving coil, MC. So where conductor continuously can be rotates here, again which cuts the magnetic lines of forces, therefore the EMF can be induced. So here the arrow indicates nothing but the current flowing through the coil or the conductor. Again, which can see the bulb here, the battery can be connected. Again, once the battery which can be applied here, the current can be flows through the bulb here and the generator can be runs, and then here bulb can be glow here. So again, yellow marks indicates is nothing but the electrons flow. Again, electrons. Again, arrow mark indicates nothing but the current flowing. And same that can be indicates here. Work is nothing but the work in progress. Again, work we can say is nothing but the some work can be done. The force acts on the body to move the body through some distance. Is nothing but we can say nothing but the mechanical work here. The work is said to be done on a body when the force acts on it and the body moves through some distance. So the SI unit of the work or energy is nothing but the joules, Newton meters or calories. So again, we can indicate again the work can be indicated by the W, that is measured in joules or the Newton meters or calories. So energy, it is defined as the capacity to do work. Units are same as work, joules, Newton meter, kilowatt hour or calories. So energy is nothing but the entire total amount of the work done in the case of electrical systems or in the case of mechanical is nothing but the energy. Again, energy we can also define as the, again energies can be indicated by the E is equal to V into I into T here. So V represents the power, T is nothing but the time taken. That is, it is nothing but the energy measured in kilowatt hour or calories. So power, we can, the rate of doing work is nothing but the power, or we can also define as the power is nothing but the P is equal to work done by time taken. Work done by time taken. So work done is nothing but the VIT. Work done in the case of electrical system we can measure is nothing but the VIT here. P is equal to work done is nothing but the V into I into with respect to the time t and time t. T and T will get cancelled, again we get the value of nothing but the power. P is equal to V into I measured in watts. So also called as the work done per unit time. It is the unit of the power is joules per, again seconds, Newton meter per seconds or watt here. So work, mechanical work. The work is said to be done on a body when the force acts on it and the body moves through some distance. This work done is stored in the body in the form of energy here. We are taking example is nothing but the bike or any car here. We are applying the force on the car or on the bike to move the bike or the car through some distance. It is nothing but the mechanical work. So in other words we can say the work is said to be done on a body to move the body through some distance here. It is nothing but the, again the this work done is stored in the body in the form of energy. It is nothing but the work. The work of energy measured in same units that can measure in joules or calories. The same unit of the work or energy is joules or Newton meters. Work done in on a body 1 joule if the force of 1 Newton moves the body through 1 meter in the direction of the force. When a force of n Newton is exerted on the body through a distance d meters in the direction of the force. The work done is equal to force into distance. Again, suppose a force of F Newton is maintained tangential at the radius r meter from O. In one revolution, the point of application of force travels through a distance of 2 pi r meters. Again, we can say it is nothing but the, again, a ring or any ear drum here where which can be rotated in the clockwise or anti-clockwise. Again the force can be applied and this motor can be moved here. The R is nothing but the radius, again where this drum can be moved. The force we can define, the force is equal to, again work done is equal to force into distance here. So work done in one revolution is equal to force into distance moved in one revolution. Fv into 2 pi r, which is equal to 2 pi t. F into r, joule or Newton meter, but T is equal to F into r is the torque. We can say if the body make n revolution per minute, then work done in a minute is equal to 2 pi nt joules. So a mass of 100 kg is raised by the means of rope passing around the pulley wheel of 0.5 diameter. Calculate the work done when a pulley makes 50 revolutions. So we can write here, again given data, that is a mass, we can write m is equal to 100 kg, diameter of the wheel, that is the t is equal to 0.5 meters, number of revolutions, that is n is equal to 50 here. So here to find work done, that is the v is equal to, work done is equal to, we can say force into distance, and formula work is equal to force into distance here. F is equal to m into g, so d is equal to 2 pi r into n. Force required is called F is equal to mg, that is 100 into 1 gram is equal to 9.81 newtons. We can say 981 newtons. Radius r is equal to 0.5 divided by 2, which is equal to 0.25 meters. Distance covered in n revolution, which is equal to 2 pi r into n, again which is equal to 2 pi into 0.25 into 50, which is equal to 78.54 meters. So total work done is equal to force into distance, that is measured in joules, 981 into 78.54, that is the 77047.0.74 joules here. So work done is equal to 77,047.74 joules. So electrical work is said to be done in an electrical circuit. Again it is nothing but the electrical work we can say here. when q amperes of second of electrical current passes through a circuit against potential difference of V volt, work done is equal to V into Q, that is a VIT watts. Second, the practical unit of the work is kilowatt hour here. Again, it is nothing but the electrical work. Electrical work is said to be done in the electrical circuit when Q amperes of the current passes through the coil or the conductor against the potential difference of V volt. So work done is equal to V into Q, VIT watt second. The practical unit of the work is nothing but the kilowatt hour. That is the one unit is equal to 1 kilowatt hour, which is equal to 1000 into 60 into 60, equal to again made in watt second. 36 into 10 to the power of 5 watt second. Again, the thermal work is said to be done by the current passing through the heater coil again as the applied voltage and heat is produced. It is measured in calories or kilocalories here. So thermal work is nothing but the, again we can express in nothing but any heater coil. So whenever we are passing the current through the again heater coil, some heat can be produced. Again it is nothing but the thermal work. It is measured in calories or kilocalories. Again example heater. Again heating elements, again it is nothing but the heater or electrical heater where the current can be flows. Some work can be done. So work units relation between mechanical, electrical and thermal. Nothing but the 1 joule is equal to 1 Newton meter, which is equal to 1 watt second, which is equal to 0.2392 calories. And an electrical bulb marked as 60 watts in connected to a voltage of 230 volts. Determine the current drawn by the bulb and the resistance of its filament. Also calculate the energy consumed if the bulb is used in a day for 6 hours time. We know that power P is equal to V into I watts. That is, P is equal to 60 watts and V is equal to 230 volts. Then substituting the values in the power expression, again we can get 60 is equal to 230 into I, that which is called I is equal to 60 by 230 is equal to 0.26087 amperes. Here the given analytical bulb marked as 60 watts. So we can say P is equal to 60 watts connected to voltage, that is a V is equal to 230 volt. Determine the current drawn by the bulb. So we know here according to Ohm's law, E is equal to V by R. So power, we can say power P is equal to V into I. So we can find the value of the current I. So I is equal to 0.26087 amperes. So from Ohm's law we know that R is equal to V by I again here, and the resistance of the bulb of the filament of the bulb, which is equal to, that is a 287, which is equal to again 881.67 ohms. Energy is equal to power into time is equal to 60 into 6 by 1000, 0.36 kilowatt hour. We have discussed prefix for SI units, correct use of symbols for SI units. So we have discussed about definitions of SI unit, SI system, work, mechanical form, solve problems, work as electrical quantity, work as thermal quantity. So which of the following correct use of symbol for SI unit? That is that again 10 Newton meters, 15 Newton meters, 20 Newton meters, none of the above. Is 15 Newton meters. The value of mega is 8 10 to the power of 12, 10 to the power of 3, 10 to the power of 6, 10 to the power of minus 6. That is 10 to the power of 6. The value of pico is 10 to the power of minus 9, 10 to the power of minus 12, 10 to the power of minus 3, 10 to the power of minus 6, power of minus 12. The value of micro, that is 10 to the power of minus 6, 10 to the power of minus 2, 10 to the power of 12, 10 to the power of 9. Minus 6. So the value of the nano is 10 to the power of 6, 10 to the power of 12, 10 to the power of minus 3, 10 to the power of minus 9. The unit of the electrical work, watts, calories, watt second, joules, nothing but the watt seconds. The unit of heat, watts, calories, watt second, joules, calories. You can ask questions about define mechanical work, define electrical work and mention the units, define the thermal work and mention the units, define the electrical energy and mention the units. Now we see the subtopic, that is the work, power and energy. The previous period we have discussed the prefix of SI units, correct use of symbols for SI units, and work as electrical quantity, work as thermal quantity. So on completion of this topic you would be able to know the mechanical power, electrical power, thermal power here. Again we know the power in the case of again mechanical and electrical power. So the power we can define the product of the voltage and the current, and total amount of the work done divided by time taken is nothing but the power here. First with the power, the rate at which the body does work is known as the power. The rate at which the body does work is known as the power. The power P is equal to work done by time taken. Force work done is equal to nothing but force into distance divided by time taken. That is the Newton meter per second or joules per second here. So mechanical unit of the power is horsepower, that is which is equal to 75 kg meters of work done in 1 second. As a 1 HP is equal to 75 kg meter per second. 1 kg is equal to 9.81 newtons. So 1 HP is equal to 75 into 9.81 Newton meter per second, which is equal to 735.5 Newton meter per second or joule per second or watts. So electrical power, the rate at which the work is done in an electrical circuit. Again, P is equal to work done in an electrical circuit by time. P is equal to VIT by T, VI watts, which is equal to V square by R watts here. I square R watts. Then we can define it nothing but the VI. V into I is equal to V by R. We can say V square by R watts here. So V square, again I is equal to V is equal to IR. We substitute here, then we get I square R watts here. So 1 kilowatt is equal to 1000 watts, which is equal to 10 to the power of 3 watts. So 1 megawatts is equal to, again mega is equal to 10 to the power of 6 watts. Given it is nothing but the thermal, that is we can say it is nothing but the electrical bulb. So we are saying the ends of the two bulbs having the two pins. The main function of these two pins is to fix the bulb inside the lamp holders here. So once we fix the bulb inside the lamp holders by switch on the light, again the current can be flow, electrons can be flows. Again here glass stem, again the current can be flow across the glass stem here, and across the glass stem. Again some here the tungsten filament can be closed and appears the light here. So the tungsten filament can be fixed like this. It is nothing but tungsten filament. It is fixed like this here. So once the current can be enters, again here due to this filament here, some light can be produced, and electrical current flowing through the filament wire is always produce the heat. That is, whenever current flows through the conductor, heat will be generated in the conductor. Relation between mechanical and electrical, nothing but the power P is equal to 1 joule per second, which is equal to 1 divided by 735.5 HP, which is equal to 1 Newton meter per second, which is equal to 1 watt here. The kinetic energy is nothing but the total amount of the work done in the case of electrical systems is nothing but the energy. The energy possessed the body due to its motion is called electrical kinetic energy. It is denoted by Ke. Examples: moving air as kinetic energy due to which it can rotate windmill. A moving train has kinetic energy due to its motion. Again, we are taking example is nothing but the kinetic energy can be obtained in the case of windmill. Once the fan rotates, again the some energy can be produced. The moving train has kinetic energy due to its motion here. K is equal to half mv square. M is nothing but the meters, v is nothing but the velocity. If a body of mass mk is moving with the speed of v meter per second, so here up it is nothing but the car or the bike which can be moved again at the upwards here. So the velocity of the body can be taken as moving with the speed of again meter per second. So we can say it is nothing but the again body or the mass. And kinetic energy possessed by the body is given by kinetic energy of the body is called half mv square joules. Examples again, it is nothing but the force is equal to 9.81 Newton, displacement is equal to 0.900 meters, work is equal to 8.82. At 30 degrees we are calculating 45 degrees force, F is equal to 13.9. Again the force can be again increases, displacement is equal to 0.636 meters. So once the force can increase, displacement can be decreases. Again the 45 degrees, 60 degrees force, F is equal to again 17 newtons, displacement is equal to 0.52. Again the same work can be done, is 0.882 time here. Again we are seeing nothing but the crane where the body can be lifted. The massive ball of the demolition machine possesses mechanical energy. The ability to do work when held at a height, it possesses some mechanical energy in the form of potential energy. As it falls, it exhibits mechanical energy in the form of kinetic energy. As it strikes the structure to be demolished, it applies the force to be displace the structure. It does work upon the structure. Conservation of energy may be neither be created nor destroyed, but one form of energy can be transformed into another form of energy, and total energy of the universal remain constant here. Again, total amount of the work done in an electrical circuit is called as a electrical energy here. So we can also express the energy as the nothing but the again E is equal to VIT joules. So VI we can express nothing but the power, T is nothing but the time taken. So electrical energy is equal to power into time. Electrical energy is equal to measured in kilowatt hours. The commercial measurement of electrical energy is in units. Electrical energy is equal to power into time, which is equal to VI into T, VIT watt seconds. So 1 watt second is equal to 1 joule. 1 unit is equal to 1 kilowatt hour, which is equal to 1000 watt hours. 1000 into 3600 watt second. 36 into 10 to the power of 5 joules or watt second. So problems on work, power and energy. So an electrical motor is developing 10 HP at a speed of 1200 RPM. Calculate torque Newton in Newton meters here. So given that is nothing but the power, that is the 1 HP is equal to we can get 735.5. 735.5. Again here given speed is equal to N is equal to RPM. 1200 RPM. Torque T is equal to we can define F into R here. So given data P is equal to 10 HP. N is equal to 1200 RPM. Torque T is equal to how much? Formula required. P is equal to 2 pi nt by 60 here. Where P is nothing but the power, N is nothing but the again speed, T is nothing but the torque. So that is 2 into 3.14, 2 pi into 200 T by 60, 10 into 735.5. So which is equal to 10, T is equal to 10 into 60 into 735.5 divided by 2 pi into 100. T is equal to 58.52 Newton meters. So the power required to drive a certain machine at 350 rpm is 600 kilowatt. Calculate the driving torque. Given data, that is the power P is equal to 600 kilowatts, N is equal to 350 rpm. To find torque, T is equal to how much? So P is equal to 2 pi N T by 60 into 735.5. P is in HP. Again, P is equal to 2 pi N by 60. P is in watt. Solution, that is P is equal to 2 pi N by 60. 600 into 103, which is equal to 2 pi into 350 into T by 60. T is equal to 60 into 600 into 103 by 2 pi into 350. T is equal to 16370 Newton meters. So we have discussed about mechanical power, electrical power, thermal power and energy. The power is given by the produced of the force and acceleration and time. Force into distance. If two identical 220 volts 4 kilowatt heating elements are connected in series across the 220 volt supply, their combination rating becomes kilowatts. 4, 2, 16. Here V is equal to 220, P is equal to 4 kilowatt. We can express P I is equal to P by V. So we get again we count consume P is equal to V into I. So we get the power value. Think of the 4 kilowatt. 1 kilowatts are equal to nearly 600 kilocalories, 860 kilocalories, 4200 kilocalories. That is 860 kilocalories. So for a given line voltage, 4 heating elements will produce maximum heat when connected, all in parallel, all in series. All in parallel. Thank you. So here define electrical power and mention the units. Define the mechanical power and mention the units. Define thermal power. Okay. Thank you.